let's give you guys some more practice. So here you're trying to build a railway track to get from A to B here, and here you've got a swamp here, and this here is normal land. Okay, so it costs $4. Unrealistic pricing, but let's just pretend it costs $4 per meter over normal land. But over to build a railway track over the swamp, it costs $7 per meter. So over a swamp, it costs a lot more. Okay, you could be tempted to build your track from here straight across here. So you've got to use Pythagoras here. But the thing is, building over swamp is very expensive. So you might be tempted to build it all the way right to the end here and then straight up. But then this here is a very long distance. Okay, so here optimize on the cost. Let's just call this x. Okay, this distance here. Don't forget you could also call this x. It doesn't really matter. But for our problem here, let's just call this x here. Okay, so find out we'll optimize this problem on price. Okay, find the value of x here where it will minimize our cost. Okay, so press pause and have a go. Okay, so this here is like to do this here, it's like Pythagoras here. Okay, so let's call it. Well, you can visualize this whole situation here as this. Hang on. So visualize as this. So this is your x here. Okay, and this distance here. Well, if this here is x, then the distance from here to here must be 1,000 take away x, and then you got to use Pythagoras here. So this distance here is this squared, which is 400 squared, and then this squared. Okay, so this distance here is given by this. This x here is given by, well, it is x. Okay, so remember along here it cost well, how much did it cost? $4. Okay, $4 to build across normal land, and across here it cost $7. So you got to get 7 times this. So the cost would be this. $4 per meter. So the cost along here will be 4x. Okay, the cost along here will be 7 times that thing there. Okay, so this is our cost, and then tidy it up, blah blah blah, tidy up, and then the cost comes to this. Okay, so now you've got in a way a graph of C versus X. Okay, so your graph is C versus X along here. So the thing is, you want to find out where the gradient will be 0. So let's differentiate it. Okay, so you've got to use the chain rule here. So from here, differentiate it. It will then give you this. Okay, so imagine this as being a bubble here. So you using the chain rule, this gets multiplied down here. That will then give you this. But then the power itself gets minus by 1. And then you've got to times with the derivative of the bubble itself. Okay, so you've got to times it with the derivative of this bubble, which will be this. Well, anyway, differentiate this. It will then give you this. Okay, so and then somehow tidy it up, blah blah blah, tidy up, blah blah blah, tidy up, blah blah blah, tidy up, and then it will give you this. Okay, so this is our derivative here. We want to find out where the gradient will be 0. So set this to be 0. Okay, set it to be 0. So that will then give you this. Okay, so you got to find the value of x here where the whole thing here will be 0. Well, just imagine it as this. Imagine it as one bubble here divided by this bubble here. So from here, multiply both sides by the bottom bubble here. That will then give you this. So when you multiply this, it will pretty much, well, 0 times this, it will disappear, leaving you 0 equals this. Okay, and then you, yeah, sorry, I've made two moves in one go here. So you add this to both sides, and then you take away this from both sides. So that will then give you this. Okay, I've taken two steps here. So you solving this is the same as you trying to solve this. Okay, and then you from here this square root is making us feel uncomfortable. So square both sides. So square this, and then here you've got 8, and then square root of whatever in here. When you square this, it will be u timesing 8, and then the exact same square root. These two will cancel each other out, the two square roots, because square, you got to square a square root, so you'd be left with this bubble really. Well, anyway, from here, square both sides, it will then give you this. Okay, so when you square this here, it will when you square this here, it will then give you this. Okay, square this, it will give you this. Okay, and then hang on, and then multiply this out. That will then give you this, and then from here, hang on, from here, take away this from both sides, and then later on add this to both sides, and then take away this from both sides. That will then give you this. So now it's just a matter of you solving this quadratic equation. So let's just, so here this is a, in a way, a quadratic equation here. So I'm just rearranging it so that we have the x squared over here, and then the x, and then your intercept here. Okay, and then use whichever method you want. Blah blah blah. Solve it. Okay, so from here, divide everything by this. That will then give you this, and then you want to complete the square. Hang on, let me think. Yeah, simplify this. It will then give you this. Simplify it even more. It will then give you this, and then from here, your eyes to zoom into this. You're going to need half of this. That's why you got a half, and then immediately take away the rubbish. So it's you really completing the square here. Okay, so hang on. From here, your eyes should zoom into these two terms, and then you're going to need half of this. So I've done a whole section on this. So if you don't understand completing the square, then track that video down and watch it. So your eyes should zoom into these two terms. You're going to need half of this, and then immediately take away this rubbish here, and then just bring this down. Okay, and then just tidy up. Blah blah blah. Blah blah blah. X equals this. Okay, so what that means is this. What it means is well, don't forget x here. Hang on, x here equals this. But the thing is, we don't want to plus this thing here. When you plus this thing here, it will take us beyond our domain. Remember, our domain is in a way 0 x. Our domain is in this is our domain. When you add this thing here, it will take you beyond 1000, which is meaningless in our scenario here. Okay, so you only want the negative version. So that will then give you this. So what that means is that you optimizing on cost would mean that you have to build along here. It will be 721.5 meters. And how much will it cost? Well, don't forget, this is our formula for the cost. So you just got to put this into the formula for the cost. So it would cost us $6,000 blah 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 dollars. Okay.